last thing here in example 6, you're going to find some complex solutions for quadratic equations. Usually when you solve quadratics, you get real solutions, which, fractions, decimals, integers, or maybe some square roots. In this case, we have some square roots, but we're going to end up with a negative underneath. So whenever you have a negative underneath your square root, that's a complex solution or an imaginary result. So if we just take A here, and we'll start you guys off with a nice easy peasy one. So if we go x squared plus 8 equals 0, we know we're going to get 2 answers because we have an x squared. So we need to subtract 8 to both sides. And we get x squared equals negative 8. And when you square root both sides, you get a plus or minus. Don't forget your plus or minus, that's where you get your 2 answers. A plus or minus negative, or radical negative 8. Now from here, you need to bring the negative out as an I. So you have a plus or minus I, radical 8. And anytime you have a radical, you have to see if you can reduce it a little bit further. Well, the square root of 8 is just going to end up being, my pen works, the square root of 8 is the square root of 4 times square root of 2, which is just
wrong.
a 2.
I put all the A's in as 10s and they're 11.
So when you simplify this
so
radical 8,
I put in like 20
you get a 2 radical 2, so your final solution gives you an x equals plus or minus 2i radical 2. And you have an imaginary root, 2, actually, you have 2 answers, a plus and a minus. And they're both imaginary. So what this really means is even though this is a graph of a parabola, it is not going to cross your x-axis. Same thing here on B. Let's go ahead and solve this. Now we can't factor, there aren't any factors of 5 that up to negative 4. If you think of factors of 5, you either have 1 times 5 or negative 1 times negative 5, and those do not add up to negative 4. So if you can't factor, then you need to use the quadratic formula. And I was trying to find a solo act to sing the quadratic formula song for you, but Mackenzie's not up for it. So anyway, I will just give it to you instead. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So there you go. That sounds better than anybody else could have done. So let's plug in our values. Well, if you look here, a is 5, b is negative 4, c is 1. So we're going to say x equals a negative 4 plus or minus, get square root of negative 4 squared minus 4 times 5 times 1 all over 2 times 5. So we simplify everything here, get rid of the negatives, so we get x equals 4 plus or minus, we get 16 minus 20 underneath, all over 10. Well, in the past, anytime you had a negative, we're going to get a negative 4 underneath your radical, you would just say, well, this has no real solutions, which is true, but we're in big boy and big girl math now, and we like to deal with imaginary numbers, just like some of your imaginary friends. So, we're going to say x equals 4 plus radical negative 4 all over 10.
I have 1b.
Well, the I is going to come out, or the negative is going to come out as an I, and then you're going to have just a square root of 4. The square root of 4 is 2. So we get 4 plus or minus 2i all over 10. And remember our rule of 3, if you have 1, 2, 3 terms that can all be reduced by something, and what we can do is we can divide all of this by 2. If they are numbers outside of a radical, so you get x equals 2 plus or minus I all over 5. So you get your 2 solutions that you had to get when you have an x squared. So I hope you guys enjoyed all of these wonderful videos. I know I sure did. So make sure that you finish up these notes, get your homework done. If you have any questions, feel free to send me a message. Hasta la vista, students.